Welcome back to our channel ClassFly community. So today we will be doing the lecture 7, that is the optical fibers, and what we will cover here are optical fibers description, construction of optical fibers, total internal reflection, propagation mechanism. So without wasting more time, let's begin. So the first thing which we will do is what is optical fiber, which we will know. So this is a picture you can see. So optical fiber looks like this. Now what is optical fiber? So fiber optics is an overlap of science and technology which deals with transmission of light waves into optical fibers, their emission and detection. So it means that these fibers are made of is overlapped with the technique of science and obviously technology. So what these optical fibers do, it transmit lights. That means it deals with the transmission of light waves which is into the optical fibers. That means this will emit and detect. Okay, so the next thing is that it is a waveguide through which light can be transmitted with very little leakage through the side walls. That means that whatever it is transmitting, so there will be a very little leakage at the walls. So it is a waveguide also. Next is, these are essential light guides used in optical communication. So it is the most essential light guides in the optical communication. Fourth is, the principle behind the transmission of light waves is total internal reflection, which you have already know what is total internal reflection. Now the fifth thing is that they are transparent dielectric. So the dielectrics are transparent and they are able to guide visible and infrared light over long distance. That means it will go long distance also. So now let's move and see what is the construction of optical fiber. So we can see a picture which occurred. Now an optical fiber is cylindrical in shape. So we can see it's a cylindrical shape. It has two things. One is the outer part and one is the inner portion. Next state that the inner part is made of glass or plastic, and this one is the core, which is the inner part. Core has the high refractive index. Now the outer part is a concentric cylinder surrounding this core and also called cladding. Cladding is also made of same material. That means the refractive index is less than the core one, and the outer part comprises of all this. The polyurethane jacket is used to enclose cladding which safeguard the fiber against chemical reaction with surrounding and also crushing. So one polythene jacket is used so that this cladding is protected. That means whenever there is a chemical reaction happening, there is no destruction happens to it. Sixth one states that many fibers which are protected by individual jackets are grouped to form a cable. That means the fibers which get protected, they are formed by individual jackets and then they are grouped. A cable may consist of 1 to several hundred such fibers. That means small fibers makes a large cable. So now we will see what is total internal reflection, and in short we can say TIR. So it is the principle behind the transmission of light waves in an optical fiber. That means optical fiber follow total internal reflection, which is a well-known optical phenomenon in physics. A ray AO, so we can see in the figure a ray which is AO traveling in a medium of refractive index. So this is the refractive index N1, which is traveling and is separated by the boundary x dash from another medium of refractive index N2. So the refractive index N1 is greater than that of N2. So the incident ray, that is AO, with an angle of theta 1 with the normal in the medium index of N1, the same AO undergoes refraction into the medium of N2 and it bends away. This is the normal and it bends away from the normal as this N1 is greater than N2, and here theta 2 is the angle made by the refracted ray with the normal. Okay, so now we will move on with the total internal in a new manner. That is what we can see, that this was the picture which we have seen earlier. So it says if we increase theta 1, that is this one, if we increase, then the value of theta 1 and theta c, which is the critical angle, is equal, and at theta 2 becomes 90 degree for such a case. So the refracted ray gazes along the boundary of separation along OB, that is this O and this B1, while incident ray is along BO. Okay, so the incident ray is this side and the reflected ray becomes this one, OB1. Now if theta 1 is greater, that means this one is greater than theta c, then incident ray CO, that means this one CO incident ray, gets reflected back into the same medium, that is it becomes OC1, which is it is incident on the boundary. This takes place as per the law of reflection. So for refraction we have the Snell's law, that is N1 sin theta 1 is equal to N2 sin theta 2. So for theta 1, when it's equal to theta c, the theta 2 is equal to 90 degree. So N1 sin theta c, if we will change the theta 1 to theta c and sin theta 2 to 90 degree, and we know that sin 90 degree is equal to 1. So we get that sin theta c is equal to what? N2 by N1. Okay. So now let's move on and let's know about propagation of mechanism. So it says that to explain the mechanism of light propagation in optical fibers. So optical fibers are devices used to transmit light effectively along any desired path. That means the light which is get transmitted along a specific path. So this optical fibers works on the principle of total internal reflection, which we just saw few seconds ago. And for total internal reflection, there are two essential conditions, that are the light ray must pass from denser to rarer medium. Okay, and the second thing is that the incident must be greater than our critical angle. Okay, now it says that a waveguide is a tubular structure through which energy of some sort could be guided in the form of waves. So this is a waveguide which is in a tubular structure, and it says that some energy which gets passes is guided in the form of the waves. So the waveguide as a light guide are also called as what? Fiber waveguide also we can say. Also we can say fiber light guide. Okay, an optical fiber consists of core and cladding. We have already seen core has high refractive index and cladding has less refractive index. In any optical fiber, the refractive index of this cladding is always less than that of the core to achieve the total internal reflection. That is, we should remember refractive index of cladding is less than refractive index of core. So when a light is incident at one end of the fiber, it undergoes a total internal reflection and finally emerges at the other end of the fiber. So it emerges at the other. It is found that the intensity of the emergent light is almost same as that of the incident light. In this way, optical fiber transmit light effectively along any desired path. In simple words, just remember that one light ray goes to the path and it has a total internal reflection, and the refracted light has the behavior same as the incident. So like this, the optical fiber transmit. So all the things are in the points form, so you can make your notes from this, and I hope all of you understood the lecture. Thank you for watching, and if you have any queries, please comment us down below. Till then, be happy and have a great day.
Wow, that's impressive! You have completed a magic today. For more videos, subscribe. Join our Facebook group and Instagram page for group discussion and live magas videos for exam preparation in an hour. We start at ClassFly community for students to learn from a friend in a simple way and support them in their own languages. If you are willing to be that one friend who saves us at the exam night preparation, then please join us by visiting classfly.in.